Construct minimal DFA that accept all binary numbers which are divisible by 7 and start with 1. Divisible by 7 we have seen in our last lecture. So first we start from there. So what will be the transition table for that? Transition table will be for 0 binary number, so 0 1 start with S0, we make a star, so S0 S1 for S1, S2 S3 for S2, S4 S5 for S3, S6, then again start with S0 and S4 and S1, S2 for S5, S3, S4 for S6, S5 and S6. Construct minimal DFA that accept all binary number which are divisible by 7. This is the transition table for that. But here one more condition is there, and start with 1. So if we write like this, then this will be wrong, because here this state will be the dead state. Why it is dead state? Because it's simply saying that it should be start with 1. So this will be the dead state, and we cannot write like this. Because this is dead state, so we can say that state is also coming in between also. So that's why there is a different way of writing it. So how we can write it? We write like this: 0 for 0 for 1. What is more important here, that it start with 1. So we do like this: 1 extra state S, and we write like this. This is dead state because it cannot start with 0, and 1 extra state. From this state to 0 transition, it will go to dead state. And for 1 we write simple S1, because 1 is possible in our DFA. So this will be the possibility that it will reach to S1. We start like this, then in the similar way as we did earlier in that table, we write like, we start with S0 and we make a star because this is initial state, and we start like this: S0 S1, and for S1 S2 S3, then S2 S3 S4 S5 or S3 S6 and S0, and for S1 S2 for S4 S1 S2 for S5 S3 S4, and for S6 S5 and S6. So and at the end dead state will come. So here we can simply see we start with initial state, in which initially we have taken, before initial state we have taken 1 dead state and 1 extra state. Why? So that it can give a transition to 0, because in our DFA what is the condition? That it should be start with 1. That's why we make 1 extra state, and for 0 transition we make as a dead state. And for 1 it is simply like S1, because it is going to the 1 transition, so we write S1. And after that we start as simple as before in our transition table. Start with initial state S0, because this is initial state, that's why we put start, and then in the similar way as we have seen in our earlier example when it is divisible by 7. And now we can clearly see that that state will come in the end, not in between, because initially we have defined. So how many states we have? 1 2 3 4 5 6 7. 7 plus 2. 7 plus 2. 7 states are these, and 2 states are these 2 states. One is dead state and one is extra state. So total we have 9 number of state. Total we have 9 number of state in a minimal DFA. Construct a minimal DFA that accept all binary number which are divisible by 7 and start with 1. So this is the way of writing when it will start with 1. We have to define one extra state and one dead state, so that there is no possibility that dead state will come in between. So for these, till now we are discussing for binary numbers. So if we write the same thing for ternary, divisible by 7 and start with 1, then how we will write? We will write in the similar way: 0 1 2 and S, one extra state, sorry, not here, one extra state, and this will be the dead state. This will be the dead state because it cannot start with 0, and this is the extra state, so that we can give the transition for 0, which is dead state. And S1, because it should start it can start with 1, so that's why we write S1, but it cannot start with 2, so we also write here dead state. And after that, in the similar way, S not star, because from here we start S naught, then S naught, S1, S2, and for S1, S3, S4, S5, and for S2, S6, and again S0, S1, for S3, S2, S3, S4, and for S4, S5, S6, and again S0, then S5, S1, S2, S3, then S6, S4, S5, and S6, and at the end dead state will come. So in the similar way we can write for ternary also, in which it is divisible by 7 and start with 1. So this is the simple way of writing. So in this way we can write, we take it one extra state, so that transition for 0 and transition for 2 can be go into the dead state, because we cannot start with 0 or 2, we can start with 1 only in the case of ternary. So how many states we have? 7. 1 2 3 4 5 6 7. 7 plus 2, this is one extra state, and these are the dead states. 7 plus 2. So total 9 number of states will be there. One is dead state and one is extra state.